In the name of God, hello guys. I'm gonna talk about the probable state in man and machine chart today. First, we have to be familiar with some expressions. Here I noted them. The first one is run, shown with R, and that means when machine works lonely, we call it R state. And service state is when operator is repairing machine. And actually machine and operator are working together somehow, we can say. Here we have P means probability that a machine is in run state, and we have Q means probability that a machine is in service state. N is the number of machines. L is time that we spend on repairing a machine. We can say service time too. And M is average time that a machine works on a single part. We have CM here, means cost of 1 hour work of the machine. CO here means the cost of operator, somehow cost of 1 hour work of operator. And we have this TEC for N, which means average cost of producing one part when we allocate N machine to an operator. And we have X for N, means average number of products that is produced in 1 hour when we allocate N machines to an operator. Here, this chart means why the problem when we allocate several machines to an operator, and it means that if, for example, this machine is running in here and it start repairing in this part, in service part, it's okay. An operator is, for example, repairing it and other machines are working. But what if three of them together at the same time need repairing? This is the problem. When operator wants to repair, for example, machine 3, machine 2 is down, can't work, and this is the time that we have lost time. We can't use all the time. For example, it's 1 hour, actually machine 2 is not running, and for that we have to calculate lost time when we have several machines. I'll explain that formulas next later actually. Here we have lost time. How we can calculate lost time actually? When we have one machine, actually there is no lost time, because when it is running, it is running. When it is down, someone is repairing it, and the machine is in a state in service time, so it's okay, we don't have lost time. When we have two machines, just we have we have lost time when both of machines at the same time need repairing. So the whole thing we have in this state column, when two of them, P was the probability that a machine is running. Actually I said in here, in here I said machine is running a state, and P is the probability that a machine is in run state, and Q is probability that a machine is in service state. And I'm sorry, we need repairing just when both of machines need repairing, and it is here. And total lost time in this condition that we allocate two machines to an operator is the total lost time is actually q square 2. For other number of machines, actually we have these calculations, and after that we have it. And for n machine, as you can see here, these calculations. So the formula for the last time is we have the formula for the last time here, sum of from 1 to n with this formula actually. And after we calculated based on the n we allocate to an operator, we calculate the last time, and then we have to calculate this. Actually we had it in here, x, where was x? X for n means that the average number of products that is produced in 1 hour if we allocate n machines to an operator. So we have here, for calculating x for n means, for example, we have a specific n, for example 3, 2, I don't know. We calculate the last time for that n and we put it here. We have n2 and we have l plus m. Actually we had it here. L and m is given is given information of the problems. Actually m was the average time that machine works on a single part, and l is the service time. So we can calculate x for n, and then we can calculate the cost. We had here TEC was the average cost of producing one part or one product when we allocate n machine to an operator. Here we have the cost of work of an operator for 1 hour, and we have the cost of the work of n machine for an hour, and we have the number of products that we produced in an hour. So we can calculate the average cost of, actually was it, yes, average cost of the average cost of the product that we produced in 1 hour when we allocate n specified n to an operator. We have to calculate it for each n. For example, we have the example here. As you can see in information, P is 0.7, Q is 0.3, L plus M is 0.6, CO is 700, and CM is 1000. We have to calculate X for each N. We have 5 N's here. For example, it was given, tell us what is the best n if we can allocate 1 or 2 or 3 or 5 or 4 or 4 or 5 machine to an operator. They say you, the problem say to you, that tells you actually the number of n's, and we have to calculate x for each n as I did it. This is the last time part. We have to calculate the last time partly, and then we do other calculations. and we have to calculate TEC for each n. This is for 1, this is for 2, this is for 3, and then we have to compare this together. Actually, the best number we can allocate is 5 due to these uh, calculations. If I did the calculation right, this is the lowest, so it is the best, and it's done. The whole example is done. um, I'll be glad if you have any question about this kind of problems. You can tell me or ask me my in the comments. I'll be glad if I can help you. Thank you for watching my video.